Hello, calculus. I wanted to show you a little bit about your classwork when I asked you to graph the derivative. So I asked you to graph the function f of x is equal to x squared, find the derivative of fx, and graph the function and its derivative on the same plane. So I'm going to do this and give you guys a little bit more to think about here. So for number one, I wanted you to graph f of x equals x squared. This is a parabola with the vertex at the origin point. Not too tough to graph. So let's go ahead and do that here. You could also do this on GeoGebra or Desmos. I'm going to do it in the Notes app, so it's a little bit easier to talk to you guys as I do it. It's a little bit easier for me to mark up too. So let's give ourselves a nice x-axis and a nice y-axis. The only benefit of having to do this online is that I can make this nice and neat for you guys. It's improved my graphs so much. Although I still would rather be there to talk to you and show you in person. So for my f of x is equal to x squared, I give myself a little table, x and f of x. And I know that we have -2, 4, 1, -1, 1, 0, 0, 1, 1, and 2, and 4. And we'll graph those points. So here's 0, 0, -1, 1, -2, 4. And then we have symmetry here about the y-axis. And so this is my beautiful parabola. Too bad there's not like a parabola ruler. So this is my function f of x is equal to x squared. We graphed it. We got it. Good to go. Second thing I wanted you to do is find the derivative. I made you do it using the limit definition. But now that we have the product rule, or the power rule, I'm going to do that. So remember, the power rule says when f of x is equal to x to the n, then f prime of x is equal to n times x to the n minus 1. So for us, f prime of x will be equal to 2x to the 2 minus 1. And that's just going to be 2x. So that's our derivative. And I asked you also to graph that on the same plane. So this is a line with a slope of 2 and a y-intercept of 0. I graph that in yellow for us. And a y-intercept of 0 and a slope of 2. So we rise 2 over 1, rise 2 over 1, and so on. Down 2 to the left 1, and I'll use the ruler here to give us a nice straight line as much as possible. And that's the graph of the derivative. And so here's what I want you to notice. I'm going to mark this up in red. The slope of the tangent line to our parabola is negative, then positive. And then at this point right here is 0. So from -infinity to 0, the slope of the tangent line to my parabola is negative. And notice from -infinity, oops, I don't know why it said -8. From -infinity to 0, this line is below the x-axis, making the values on this line negative. From 0 to infinity, the tangent line is positive, and the slope is positive. And that's really all I wanted you to see, is start to try to draw these connections between the graph of the